Hello and welcome. In this video, we will explore the science of sound. You will learn about sound characteristics, frequency and wavelength, velocity of sound in different media, and how loudness is measured using decibels. Let's begin. Sound is a mechanical wave. It is produced by vibrations. When an object vibrates, it creates compressions and rarefactions in a medium such as air, water, or solid materials. These pressure variations travel outward and reach our ears. Remember, sound cannot travel in a vacuum. Pitch tells us how high or low a sound is. It depends on frequency. A higher frequency creates a higher pitch sound. A lower frequency creates a lower pitch sound. Loudness depends on amplitude. A sound with larger amplitude feels louder. A sound with smaller amplitude feels softer. Volume controls on speakers change amplitude, not frequency. Timbre helps us identify the source of sound. Two sounds may have the same frequency, but feel different because of their waveform, harmonics, and overtones. This is why a flute and a violin sound different even when playing the same note. Intensity is the power carried by sound waves per unit area. It is measured in watts per square meter. Intensity decreases as distance from the source increases. A tone has a single frequency. A musical note has a mixture of pleasant frequencies. Noise contains irregular and unpleasant vibrations. When sound reflects from a distant surface and returns after 0.1 seconds, we hear an echo. Reverberation is the persistence of sound due to multiple reflections. This concept is used in auditoriums and sound engineering. Frequency is the number of vibrations per second. Its unit is hertz. Humans can hear between 20 hertz and 20,000 hertz. Wavelength is the distance between two consecutive similar points on a wave. For example, crest to crest or trough to trough. Higher frequency means a shorter wavelength. Lower frequency means a longer wavelength. The relationship is given by the equation: velocity equals frequency multiplied by wavelength. This formula helps us calculate sound speed under various conditions. Sound travels slowest in gases, faster in liquids, and fastest in solids. Approximate values are: air, 343 meters per second; water, 1,500 meters per second; steel, nearly 6,000 meters per second. Higher temperature increases the speed of sound. The formula for air is velocity equals 331 plus 0.6 times temperature in Celsius. Humid air carries sound slightly faster than dry air. Sound travels faster downwind and slower upwind. In gases, higher density reduces sound speed. In solids, high elasticity increases the speed of sound. A decibel is a logarithmic unit used to measure sound level. Human ears respond logarithmically, so decibels help represent loudness more accurately. The formula is sound level in decibels equals 10 times the log of intensity divided by reference intensity. The reference intensity is 1 times 10 raised to the power minus 12 watt per square meter. Here are typical values: whisper, 30 dB; normal conversation, 60 dB; busy traffic, 80 dB; factory noise, 90 dB; rock concert, 110 dB; jet engine, more than 140 dB. Above 120 dB, sound becomes painful. You learned how sound is produced, how its characteristics shape our hearing, how frequency and wavelength are connected, how sound speed changes in different media, and how decibels help measure loudness. Thank you for watching.